To week 2, we're going to go over a few more of the intros, some more intro information into what we're trying to do and how to use some of these really cool tools. So I'm going to go ahead and preload one of my other tools, but one of the things that you guys will want to think about as you're starting to go through some of these processes is this next segment that we're looking through. And what we're going to be doing is we're going to be going through each week one of these segments. In this one, wisdom is one of the big topics. So wisdom is good with inheritance and an advantage to those who see it, who see the sun. And the protection is like the protection of money. And he separates out here the knowledge and the wisdom that's actually doing the preserving of the life of him who has it. So why is this so important? This is a very important aspect of what we're trying to do and trying to teach you guys as you're going through these processes. So we're trying to literally teach you guys how to think your way out of a wet paper bag. It sounds a little absurd, but the reality is the majority of the people around you are greatly lacking in wisdom. Certainly the people that often are making very big, important decisions are severely lacking in wisdom. And so he separates out here the difference between knowledge and wisdom. This distinction is important because knowledge is a collection of facts. This is a coffee cup. This was built by something that was programmed and produced by some kind of machine. I filled it with another kind of machine that was produced, and as it is empty, I need to hurry up and finish this so that I can go and fill this with yet a different machine that was also built by something that was programmed. But all of that is just knowledge. None of that is wisdom. Wisdom actually imparts the ability to make wise decisions, the ability to make good use of the information in the knowledge. So you can see very easily, you can have a condition where someone is full of knowledge and yet utterly devoid of wisdom. Mostly they call them politicians. But the reality is we have a situation where we want to teach you how to rightly use the information that you have so that you can make good decisions on some of the things that you're going through. So in class, we ask about what is actually trigonometry and how this functions and what all of this stuff means in order to get some sense of where everyone is in the larger scope of things. So we get a bunch of feedback, and then we go through this in order to show some of the things and activities that you guys are going to be doing will seem a little bit silly at the outset, but they're things that I think are going to be very important for many reasons. When Pythagoras was going through and drawing things in the sand and calling people over and saying, look, come here, you got to see this is really neat, and people were sitting there going, okay, man, you're drawing a bunch of boxes in the sand. I'm just not quite getting why this is so interesting. He probably looked a little bit silly to some of the scoffers that were there in his presence. But you guys will get to do a whole bunch of activities and look a little bit strange yourself today, so this is part of what we're going to be doing. So we're going to be installing MATLAB Mobile. If you haven't already, go ahead and grab that from whatever your particular app store is. And then on the left side, what we're going to do is select from the menu. We're going to go over to Sensors. And at the top, we're going to set it Stream to, and it'll be the log. So we actually want to log it locally on the device. It will upload through wireless, cell data, etc. Unless, of course, you're connected to the WGCU Secure. You will want to switch over to either the LOPS network or to cell data in order to get it to actually upload to MathWorks, but we'll cover why that's important in a little bit. So you scroll down to the orientation, and that's the sensor set that you're going to turn on. You don't want any of the others. You don't want angular velocity, position, and some of the other things. The GPS data won't be particularly helpful for you at this stage. We'll do that later in some other labs. So the orientation is going to give you 3 pieces of information, and as you move the phone around, you're going to see some different kinds of data showing up. So you're going to be able to see the azimuth, which is your horizontal angle, the angle along the horizon. You have your pitch, which is your y-axis, so up and down. Then you have your roll, which is the actual roll of the device. And you'll see that you can change and rotate the device to change the display like a lot of apps, that part you guys are used to. Why that's useful is it allows you, when you're looking at an object, to be able to line up along the plane, the edge of your device, or along the plane, the edge of your screen, and keep your eyes in alignment as you're looking at an object, and making sure that you're standing erect, you're standing with your eye line at a consistent point instead of changing, dipping, moving, doing strange things that are going to change your height to your eye line. And we're going to talk about why that is. So to start a log, you hit start, and then you line it up and leave it there for a second or two, and then you hit stop again, and that records your data set. And we'll talk about where that actually goes. That goes into, you'll see under your files, this is what's in your MathWorks files. Now, because this disconnected in some of the other things that we're doing here to try and prepare today, it needs a refresh periodically, but you'll see a file named mobile sensor data, and that's where your actual files will show up. So you can log in to mathworks.com, and that's what we're going to do here, is we're going to log into MathWorks. And we will see, if we go over to MathWorks, what we'll see is we will see when we go to log in, you'll enter your GCU credentials, you'll see both the MATLAB Drive and MATLAB Online. So we'll just go to the Drive first. You'll see the mobile sensor data and your logs that you've recorded. So these you can download. This is also a place that you can upload some files if you're going back and forth, if you're on a stranger's computer, or you're working from somewhere else. This allows you some flexibility in how you actually do the mechanics of operation for the class. Now, you can also go to MATLAB Online. There's some more details that you guys will see in the support video to this. So there's already a video on the data analytics and the process of going through MathWorks in order to make some of these things happen. So what these will do is the MATLAB Mobile will allow you, initially this will show up grayed out, and what you'll have to do is you'll have to right click, and it'll say add to path, and you'll say folders and selected subfolders. So it'll look grayed out like this. You're going to right click, add to path, selected folders and subfolders. Now what this will allow you to do is this will allow you to have access to all of these files. Then you can open up whatever you named the angle files. It'll generate the timetable, and this will allow you to take a look at some of the other things that we're going to be doing. So you have your azimuth as your first column, you have your pitch as your second column, and you have your roll as your third column. So this is the column that we're interested in. You can't just copy and paste this into Excel in most instances. There are a couple versions of Excel that will allow you to, but we're going to show the entire proper way on how to extract the data. That's already in another video, so go take a look at that one. What we're going to do additionally today is use a new kind of tool that will be this one. So this used to be a protractor, but now it's a custom designed engineering tool. So what does that mean? That means we have a sight tube along the top. It's very high tech. We spared no expense in developing this particular lab. So this sight tube allows us to find an object and find where the top of that object is. By having the string positioned and hinged right at the center line where all of these actually intersect, you have the ability to see where the angle is. But one of the problems that you'll find is, as you measure the height of something, you'll have to stop this. And so this is somewhere on the order of 75, probably 76 degrees. But by inspection, you can see this is not exactly a 75-degree angle. So you have to keep in mind all of that stuff that you thought you were never going to need in real life in trig. Turns out you actually need it all the time, and if you do budgeting, that level of math actually even helps you that much more, because you figure out that credit cards are a really bad idea. But that's another lecture for another day. So the 75 degrees is obviously the complement to this angle, meaning that you have your 25 degrees and your 75 degrees is the opposite for what you're working with. So you go back to your trig identities and you know something about how far away you are from the object because you measure it using a handy dandy tape measure, and we'll go over the equipment in the next part of the video. But you'll make these and this inclinometer similar to inclinometer apps. Will do the same sort of thing that you can use as an angle finder. You'll be able to visualize the top of something and record the angle. Then you have to think about, okay, we're going to figure out what the height of that distance is, that height, and that's the triangle that sort of sits on top of the rectangle defined by the height up to your eye line. So that rectangle, that height plus the height of the triangle for the object that you see based on how far away you are in those trig identities, that's what gives you the information about how high or how tall something is. So if you guys are doing this remotely and under various circumstances, you can still use this MATLAB mobile method as well as another inclinometer app and do the same sorts of estimations. You start with something that is approximately at a known height. So if you're stuck in quarantine or something else, you might measure the height of a door, you might measure the height of a lamp or something like that. You might measure the height of bedpost, whatever stuff you have available that you can reasonably estimate what that height actually is. And if you don't know what your height is, then you can use other methods, connect up a bunch of soda straws as tall as you are, and you should know about how tall you are, and then use that to measure or estimate. So the idea is to try and use the tools that are available to you to be able to make measurements and informed decisions about the things that are around you, the things that you're measuring. Another thing that we want to do is we want to be able to calibrate, and that's part of what you guys will see as the next part of this process. So we'll cut here and switch over to the actual operations and a quick overview of the equipment. So here we have a strange device that we're going to be using today. It's called a tape measure. What we're going to be doing is measuring the distance away from the object because we need to be able to do calibration. Calibration is the process that we use in order to understand whether our tool is telling us the right kind of information. So the concept is we're going to figure out how tall this is. We're going to say the distance needs to be approximately 6 feet away that we're measuring. The height is going to be here, 39 inches from something. So we need to figure out what the total height is. And the height 1 is the height from here to here, and then our height 2, so this one we don't know yet. So we have some height from here to here. This is really perhaps more appropriately our H1. This is our height up to our eye line, and so we need to have some sort of a sense of exactly how tall this is. So we use this tape in a couple different arrangements, one of which is to determine just how high the object is. And if you are watching this remotely, going through this process, one of the things you may end up needing to do is you may end up needing to take a measurement using your own height as some kind of guideline or whatever else. We learn how to use the tools at our disposal to be able to get an actual height. So this one is just shy of 6.5 feet, 6 foot 5 inches to the top. And we are also going to measure 6 feet away from the base. So we want to make sure that we've included that ring. And so 6 feet away from the base is what we're going to be working with. So from that 6 feet, what we're going to do is we're going to take our custom-made tool here, and we're going to measure from our eye line here. We're going to measure from our eye line to, we're going to set our overall height. This is the total height. So this is some variable that we're going to fill in, 39 inches. the total height up to this top point, we actually know as 6 feet and 4 inches. So 6 feet is 72 inches. I need another coffee already. 72 and 4 should be 76 inches. So 76 inches is what we're trying to figure out based on the height 1 and the height 2. So if I take my eye line as I'm standing properly, my eye line sits right about here. So this is 76 minus 27. So this would be my height 1. 76 minus 27. Actually minus the difference between 39 and 27, which is 12. So that's about 1 foot shy. It's right at about 5 feet, I guess. 5 foot, yeah, it should be right at about 5 foot or so. So 76 minus the 12 gives us our 64 inch that is calibrated to me. So what we can do is we can measure using our starting point at 6 foot distance. We should be able to see what our height is. So for me, that angle appears to be right at about this 75 degrees or so. Try and make that visible. It'll be a little hard to demonstrate on camera, but you'll get the idea. It's about 75 degrees, and now we know something about how this actually functions. So our measured angle was about 75 degrees, which we know actually becomes, as the complement to that, that becomes 15 degrees. So 15 degrees, we plug into our math, and we say we want to figure out what height 2 is. And this is the thing that we're trying to understand. So we start from our trig process, and we know, because of the sum total of what we learned in trig, the tangent of this angle, in this case our 15 degrees, is equal to the opposite, or our height h2, over the adjacent, which is 6 feet. So now we rearrange this algebraically to solve for h2. We add h2 and h1, and so this, our total height, should actually be 76 inches. So now h1 plus h2 is equal to what? Is that equal to 76 inches? Do we actually get something like 80 inches? So 80 inches, maybe. In that case, what we're going to do is we're going to take for both our phone, our digital data set, and for our inclinometer or inclinometer app as whatever we tend to be using for this particular application. So we're going to take the inclinometer data, we're going to fill in a table, and what we're going to do is, if you're able to go out and do the events around the campus, the Jerry Colangelo statue. And we might come up with something like 9 feet for the inclinometer measurement and 10 feet for the app. So what we're not trying to do is we're not trying to report just a bunch of raw angles. We're trying to turn those back into heights that we then turn into the composite height. So the height of that rectangle where you're looking as the person, that rectangle plus So the rectangle here, so this would be your H1, and this is your H2. By combining H1 plus H2, you get the total height. And that's what we're trying to establish for the baseball stadium outside, as well as the circle window on building 18. So if you haven't figured out which one that is, you'll find out. We take the difference by subtracting the app measurement, so the phone app versus the inclinometer. Maybe it's two different apps, you're subtracting the differences. Relative to the inclinometer, because this is a physical measurement, we should have some sense of how well calibrated it is. The difference between those divided by whatever our basis is, the thing to which we are comparing as the standard, in this case the inclinometer, times 100% gives us maybe around 11% difference. And so that's what we're trying to find as our percent error difference between those things. If you're in quarantine, you're probably doing 3 different things. You're doing the bedpost, you're doing the height of the shower head, and you're doing the height of lamp or something, right? So even if in the case of something like a lamp, you might actually have an inclination downward where it's below your eye line. That's okay too. So there's ways to figure out what that math looks like, and especially in the case of the app, you want to be paying attention to the fact that it's going to give you a negative angle when you're using the phone app, which comes from this. You have a negative angle, so this is the negative theta, this is the positive of theta because of the parallelogram behavior here. So you have a line intersecting this parallelogram, the horizon of your eye line and the horizon of whatever top plane, something like you can think of the ceiling if you're measuring the height of a projector or something like that. So this is what we're going to put into the table that's going to summarize your key results from this lab. That's what's going to go into your report process. So you want to make sure you've got your abstract. You want to make sure it's very detailed and summarizes all of the key results, especially the numeric results. You want to cover what are the objectives, what are the purpose of what you're doing, and introduce the topic, including a little background about the way trigonometry is used in this way. And thereby, we get into our background and theory section where we talk about some of the applications of trig to determine the heights of objects. And that's very helpful to consider that this is how, for instance, somebody would have done a tree trimming estimate in the early days before even calculators and other things. They would have done the math by using an inclinometer to tell how high things were, because that was the only way they could measure it. So this is why people were a whole lot smarter than we are now, just relying on Google. All right, so that's what your data analysis is going to look like. You guys go ahead and start doing the data processing, and then we'll see you probably on the troubleshooting videos for some of the deeper dive on the data analysis for doing the MATLAB data pull. Enjoy!